Your brain has 86 billion neurons, constantly firing, learning, adapting. Scientists asked, can we build something like this in a machine? That question gave birth to neural networks. Today we explore what they are, how they learn from data, and why they power everything from your phone's face unlock to self-driving cars.
Everything starts with one tiny unit, the neuron. In your brain, it receives signals, processes them, and decides whether to fire. In a neural network, we copy this exact idea, but with numbers and math. Understanding one artificial neuron is understanding the entire foundation of modern AI.
In 1957, a scientist named Frank Rosenblatt built something revolutionary, the Perceptron. It was the very first artificial neuron that could actually learn from data. Simple, limited, but the seed of everything. Without the Perceptron, there would be no ChatGPT, no self-driving cars, no modern AI.
One neuron is smart, but one neuron alone is limited. The real power of neural networks comes when we stack neurons into layers, an input layer that receives data, hidden layers that find patterns, and an output layer that gives the final answer. Layers are what turn a simple perceptron into modern AI. Once layers are in place, data needs to travel through them. This journey from input to output, moving forward one layer at a time, is called feed forward. No going back, no loops, just pure forward movement, calculating, transforming until the final answer appears. This is how every neural network makes a prediction.
After every neuron sums its inputs, something crucial happens. An activation function decides how strongly should this neuron fire. Without it, the entire network collapses into simple math that can't learn anything complex. Activation functions are the secret ingredient that gives neural networks their real power.
The network made a prediction, but how wrong was it? That's exactly what a loss function measures. It takes the predicted answer and the correct answer, compares them, and produces a single number, the loss. The higher the loss, the worse the network is performing. Training is simply the mission to make this number as small as possible.
The network predicted wrong. The loss measured the mistake. Now comes the most important moment, fixing it. Backpropagation travels backward through every layer, every weight, asking one question: who was responsible for this error? Once blame is assigned, every single weight gets adjusted. This is how neural networks actually learn.
Backpropagation knows which weights to fix, but how exactly do we fix them? The answer is gradient descent. Imagine standing on a mountain in complete darkness, trying to reach the lowest valley. You feel the slope under your feet and take one small step downhill at a time. That is exactly what gradient descent does. Step by step, it finds the lowest possible loss. And that is when a neural network truly masters its task.
You started knowing nothing about neural networks. Now you understand neurons, perceptrons, layers, feed forward, activation functions, loss, backpropagation, and gradient descent. You understand how machines learn. But this is just the beginning. What comes next will completely change how you see artificial intelligence. Subscribe and stay close. You do not want to miss it.